Now we're going to use elimination to solve systems with more equations. A little bit of terminology first. A system of equations is called square if the number of equations equals the number of variables. So this is an example of a square 3x3 system. 3 equations, 3 variables. A system of equations is called homogeneous if the constant terms are all 0. So this one is not homogeneous because its constant terms are non-zero. Now, when you have a system of more than 2 equations, it's a little hard to solve by graphing because we're just not very good at graphing in 3 dimensions. And it's a little hard to solve by substitution because if I were to solve this equation for x and plug it in, I still wouldn't be able to solve for a variable. I'd have 2 left. So the best method to solve these bigger systems is repeated elimination. And our goal is to actually put it into something called triangular form. And you'll see what that means as we get further in the problem. I look at this and I say, I want these 2 x terms to disappear. Okay, so that x is only present in the first equation. Okay, so I'm going to use elimination to do that. I notice that if I multiply the first equation by -1, and then add it to the second equation, my x terms cancel. And I get an equation without x in it. Similarly, if I multiply the first equation by -2 and add it to my third equation, the x terms cancel, and I'm left with an equation without any x's in it. So now, instead of solving this system, I'm going to solve an equivalent system, one that has the same solution set, but is a little bit easier to solve. Okay. Now, my next goal is to get rid of this y term. Okay, so I notice that if I multiply the second equation by -1 and add it to the third equation, the y terms cancel and I get an equation with just z in it. So now I'm going to have another equivalent system where the first equation is the only one with x. The second equation has no x, but then a y. And the third equation has just z in it. And you notice that it looks like it forms a triangle. So this is called triangular form. And from here, it is now easy to solve the system. So we immediately should be able to tell what the z term is. If we take this last equation, we get that z equals 1. Now once we know what z is, I'm going to take it and plug it back in to the second equation, and I'm going to be able to solve for y. So 3y plus z equals 7 gives me y equals 2. And once I have z and y, I'm going to plug them into my first equation, and I'm going to be able to solve for x. And I get that x is -3. So my solution for the system is -3, 2, 1.